This topic is controlled access. In controlled access, the station consult one another to find which station has the right to send. But in the case of random access, there is no such thing. But in the case of controlled access, the station consult one another to find which station has the right to send. A station cannot send unless it has been authorized by other station. Three popular control access methods are there. First one is reservation, second one pooling, and the third one token passing. So totally you're having three methods in this controlled access, that is reservation, pooling, and token passing. So first one, reservation. In the reservation method, a station need to make a reservation before sending a data. If you want to send some data, then it has to reserve. The time is divided into intervals. In each interval, a reservation frame precedes the data frame sent in that interval. So this is a reservation frame. It is having some interval. So here, the first time slot, the station 1 has reserved, and here in the first time slot, the first station, and the third time slot, the station 3, and the fourth time slot, the station 4 has reserved. So if they want to send some data, it has to reserve the frame. So if there are n station in the system, there are exactly n reservation mini slot in the reservation frame. So this is a reservation frame. If you're having 5 station, then you'll be having 5 mini slot. So each mini slot belongs to a station. So if the particular station wants to send the data, it has to reserve its frame. So the station that have made reservation can send their frames after the reservation frame. Second method is pooling. Pooling works with the topology in which one device is designated as a primary station and the other device are secondary station. So this pooling can be done when you are having a primary secondary relationship. If one station is a primary station and another station is a secondary station, then you can use this pooling. So all data exchange must be made through the primary device even when the ultimate destination is a secondary device. The primary device controls the link. The secondary device follows its instruction. So it is up to the primary device to determine which device is allowed to use a channel at a given time. So the primary device therefore is always the initiator of the session. So this is the primary device and this is a secondary device. So the primary device will select the particular secondary device and the secondary device will send the acknowledgement and the primary device will send the data and again it will send the acknowledgement. So first this primary device is sending one pooling and it is sending a negative acknowledgement. So it is again pooling the next device, next secondary device, and it is sending the data and then acknowledgement. So this is there are two functions, select function and pool function. The select function is used to transfer data from primary to the secondary station, and the pool function is used whenever the secondary needs to send some information to the primary. But it is also initiated by the primary. The primary will first ask the first secondary station. It will send a pool and it will ask the station A whether if you have any data, please send. If A is not having any data, it will send a negative acknowledgement. Then it will pool the next station. Then the next station, if it's having data, it will send. Then after receiving that particular data, the primary will send the acknowledgement. So if the primary wants to receive data, it asks the secondaries if they have anything to send. This is called pool function. If the primary wants to send data, it tells the secondary to get ready to receive. This is select function. So the third method is something called token passing. In token passing method, the station in a network are organized in a logical ring. So each station there is a predecessor and a successor. The predecessor is a station which is logically before the station in the ring, and successor is a station which is after the station in the ring. The current station is a one that is accessing the channel now. The right to this access has been passed from the predecessor to the current station, and from the current station to the successor station. So a special packet called a token circulate through the ring. If any station want to send some data, it will take that token, and after sending the data or while sending the data, it will be holding the token. After sending the data, it will release the token. The position of the token gives a station the right to access the channel and send its data. When a station has some data to send, it waits until it receives the token from its predecessor. It then holds the token and sends the data. When the station has no more data to send, it releases the token, and it will be passing to the next station in the logical ring. The station cannot send data until it receives the token again in the next round. So these are the some of the logical ring. This is a physical ring, and this is a dual ring. This is a bus ring, and this is a star ring. These are the some of the ring topologies for token passing.